In this video, we're going to talk about how to complete the technology portion for your Week 6 discussion board in Math 203 using Excel. This example is going to use the two columns of the airport data, Sprint and T-Mobile. Please make sure that for your assignment you are using the correct columns as outlined in the directions. So the first thing we were asked to do in this assignment is to find the mean of the carrier speeds for each carrier. So that means I need to find the mean speed for the Sprint data and the mean speed for the T-Mobile data. So let's do that. So the mean for Sprint is going to be, I'm going to go ahead up to the Formulas tab up here and then go to More Functions, Statistical. And if you remember back to a previous week, the formula for the mean is called average. So we'll select average. And then I'm just going to go highlight all the numbers in the Sprint column, not including the word Sprint at the top, just the numbers for the actual data, and then click OK. And so now I have the mean data speed for Sprint, it's 3.7. Likewise, I'm going to find the mean for T-Mobile. And I just like to resize my columns each time so nothing gets cut off. So the same way, I'm going to go Formulas, More Functions, Statisticals, Average, and then I'm going to go highlight the numbers for T-Mobile. And click OK. So now I have the mean speed for T-Mobile and the mean speed for Sprint. So just at a glance here, it appears to me that T-Mobile is faster because the speed is much greater than it is at Sprint. So that's my hypothesis at this point. I would claim that the T-Mobile speeds are faster than the Sprint speeds. So for part 2, we need to make a confidence interval. Now to make a confidence interval, the first thing we need to do is actually find the difference in the speed for each airport. Notice that here in the first column they tell us each airport that these measurements came from. And for each airport there's a pair of data, the Sprint number from that airport and the T-Mobile number from that airport. So since this data is paired, I would like to find the difference in the speed for each airport. I'm going to go ahead and do that over here. I'm going to say Sprint minus, not Spring, Sprint minus T-Mobile. And in each row here, I'm going to go ahead and subtract the T-Mobile speed from the Sprint speed. I can do that by starting an equal sign to make my own formula. I'm going to go ahead and click on the Sprint number from this first row and then subtract. Click on the T-Mobile number from this first row and hit enter. So my formula now is taking the Sprint number and the T-Mobile number from the same row and subtracting them. So I would like that to be in every single cell for the totality of my data here. So if I click on this and if I highlight over this little itty bitty box where the plus sign comes up, I can drag this down all the way until the very last one, and then release the mouse, and now that formula has populated to every single row, so I now have a whole column that shows me the differences for each row. To make the confidence interval, I need two things. I need the point estimate, which will be the mean of the differences, in other words, the mean of this new row that we just created, and I need the margin of error. So let's find those two things. So the mean of the differences, we're going to go ahead and find the mean of that new row that we calculated right here. Same way we did before, we're going to go Formulas, More Functions, Statistical, Average. And now we're going to go ahead and highlight the columns in that, or the cells in that new column, and click OK. So the average difference when I subtract in this order is negative 7.3. It also turns out that to get the margin of error, which we're going to do next, we're going to need the standard deviation of this column that we just created. So let's go ahead and do the standard deviation of the differences. And that's going to be Formulas, More Functions, Statistical, all the way down to the S section. We're going to look for standard deviation.s, stdev.s. That means standard deviation of a sample. So we select that, and then we're going to go all the way down and highlight that entire column and then click OK. So we're now ready to get the margin of error for our confidence interval. The function we need for that is again under formulas, more functions, statistical, and we're going to go down here till we see confidence. Now notice there's two options for confidence, confidence norm and confidence T. So confidence T is what we want when we are doing a confidence interval about a mean, and we do not know the standard deviation from the whole population. We do know the standard deviation from the sample, but we don't know it for the whole population. So that tells us we're using the T distribution. So we're going to select confidence T. The first thing it wants to know here is what your alpha value is. So remember, in the directions you were told to do a 90% confidence interval. So that means the alpha level is going to be 1 minus 0.90, 1 minus that 90%. The next thing it wants is the standard deviation. Well, we just found the standard deviation a moment ago, and that number is right here. So I'm going to go ahead and just click on that cell right here. It's going to pull the cell number down here for me, so it knows now to just go look in that cell whenever it wants the standard deviation number. And the size here is the size of the sample. So if we scroll down, we can see that we end here on the 51st row, but the first row was just the titles of the different columns. So there were 50 numbers here, 50. So that's it, that's all we need there. So we click OK. And now we have the margin of error for our confidence interval. So a confidence interval is two numbers. There's a lower limit and an upper limit that form a range or an interval. So we can calculate the lower limit and the upper limit very easily now that we have these things. So the lower limit and the upper limit. So remember, the lower limit is just the mean minus the margin of error. So we can create that simple formula ourselves. When we want to make our own formula, we start with an equal sign. So again, it was the mean, which was right here, minus the margin of error, which was here. Once I have that entered, I just click enter on the keyboard. So the lower limit here is 9.6, negative 9.6. The upper limit is the same, but now we are adding. So we're going to put an equal sign, and we're going to take the mean plus the margin of error. So this is my confidence interval. The confidence interval is negative 9.6 to negative 5. So what we notice here is that 0 is not in the confidence interval. What does that mean? Well, what it means is that when we subtract the values from our Sprint data and the values from our T-Mobile data in this order, Sprint minus T-Mobile, we are not expecting to get the number 0 as a result of that subtraction. Well, remember, the only way two things can be the same is if when we subtract them, we get 0, right? If we subtract two numbers and we get 0, that means the two numbers were the same in the first place. But here, since 0 is not in the interval that we're expecting the true value from the population lies, then we do not expect that this subtraction is going to yield a 0 for us. In other words, we don't expect that the Sprint numbers and the T-Mobile numbers are the same. So there's our confidence interval. Finally, we need to do a hypothesis test to, again, try to confirm these results that we're getting from the confidence interval. So for this one, you can either use the formulas in the book, and we saw some examples of how to do that in Excel in the My Math Lab homework videos, but you can also do this. You can go to Data at the top, and then go over here and look for Data Analysis on the side. If you don't see Data Analysis under this Data tab, you can find it by going to File, Options, Add-ins, Manage Excel Add-ins, click Go. And then you want these first two boxes to be checked. If they're not checked, go ahead and check them and then click OK. And then under the Data tab, all the way on the right, you should see Data Analysis. So if we click on Data Analysis, what we want is t-test paired to sample for means. That's what we're doing here. We're doing a t-test about two paired samples, the Sprint and the T-Mobile in this case. So if we click OK, the first thing it wants to know is what the range of values are for our first variable. So that was Sprint. So I'm going to go ahead and come over here and highlight the Sprint column. Notice I did in this case highlight the title at the top. For the second, we want to highlight the T-Mobile. Again, in this case, I am highlighting the title at the top, and then I'm going to make sure that this box is checked that says labels. So if I check that box, Excel will know to ignore that first row because it just has labels in it, nothing else. The alpha value for our hypothesis test is 0.05, so we're going to type in 0.05 right here. That was given in the directions. Now for the output here, usually this box will be checked automatically, and if you leave this checked in this way, you will have your results displayed on a separate worksheet. I prefer to display it on the same worksheet, so I'm going to click Output Range, and then I'd like my data to show up right here. So I'm going to click here into this cell and then click on the cell where I want the data to appear. Sorry, I forgot to say the hypothesized mean difference here should be 0. So if that's not already there, please make sure you type 0 in there. We're hypothesizing here that either the null hypothesis is going to say that the mean difference is 0, in other words, Sprint and T-Mobile are the same, or the alternative hypothesis will say that they're not equal to 0. Indeed, it will be less than 0, meaning that the two numbers are not the same and Sprint is slower. Once we have all of that, we can click OK. And now we have all this information about our test. So again, we happen to see we get the means again. We already had that information here, but we have the means again if we want it for some reason. We know again that we have 50 data values in the set. And the number that we're looking for is this p-value right here. I'm going to go ahead and just throw a highlight on that. So that is the p-value for a one-tailed test. In your write-up, you already will have written down the null hypothesis and the alternative hypothesis, but just to say it here in words, the null hypothesis would say that the mean of the differences is 0. In other words, the Sprint speed and the T-Mobile speed are the same. The alternative hypothesis would say that the difference is less than 0. Again, if we're subtracting in this order, Sprint minus T-Mobile, and if we believe that Sprint has a slower speed, that means Sprint will in general be a smaller number. And if we take a smaller number and subtract a bigger number from it, we expect to get something negative, less than 0. So that would have been our alternative hypothesis. So here, this p-value is very small. Don't be tempted to think that this p-value is 1.07. It's not. If you look at the end of the printout here, you see the E minus 06. So what that means is that this number is in scientific notation. So actually what you need to do to get that number into a sort of standard quote-unquote normal form is you'd have to move the decimal point 6 places to the left to get the actual number. Or you can have Excel do this for you. If you go up to the number tab right here and click on this little arrow, you can change the formatting of the number. You can make it number right here, and you can take it out to as many decimal places as you want. I'll go to 6 and click OK. So this is the actual number in like a standard form for our p-value. In any case, this p-value is very small. It's certainly less than our significance level, the alpha, which was 0.05. So remember, when the p-value is less than the significance level, we will reject H0, reject the null hypothesis. When that is not the case, then we would fail to reject the null hypothesis. So here we will definitely reject the null hypothesis, which again said that the Sprint and T-Mobile values were the same, and we have supported the alternative hypothesis, which says that they are not the same, and indeed the Sprint speed is slower than the T-Mobile speed. So that's it. That's all you need to do for your technology portion for week 6.